Hi guys, and welcome back to this last video of the series on surds. We're going to be doing some examples of rationalizing the denominator, which was explained in the previous video. Now, the examples that we're taking in this video come from the New Century Maths Advanced textbook for Year 10, and we're going to be doing the last question of all the tricky ones. Okay, so this is question 2 because question 1's a multiple choice, and this is part L of question 2. So, let's get stuck into this one. Now, straight away, I can see that the denominator is not rationalized, so I want to rationalize this denominator by utilizing my rule. So I'm going to times this bottom by root 5 on root 5, because I know that timesing these two together will, using the property of this, we know, or vice versa, will result in A, or whatever number's under the bracket. So you'll see here, so remember there's an invisible 1 out the front of here times the coefficients. 4 times 1 for our denominator coefficient is 4. Root 5 times root 5 is root 25. Okay, and we know that this denominator now is going to be 4 times 5 because root 25 is 5, which is the same thing as 20. So let's clean this up. Okay, so we have 20 on the bottom now, which is a rational number. So we've done this part now. Now we just need to make sure that we're timing the top so that it's the same fraction as over here. So what we've got to do is we times our 5 by our 1 to get our coefficient, which is going to be 5. And then we're going to times our root 3 times our root 5, which is going to be root 15. Now this is most likely going to be our last form, but we should think, does this 15 here have any square factors? 9 go into it? No. Does 16 go into it? No. So we can just leave this how it is, and our final answer is going to be 5 root 15 over 20. Okay, so we're on part D now of question 5. We've skipped question 3 and 4 because they're also multiple choice questions, so we're not going to bother with them, and they're just more of the same anyway. So, looking at this, I can see that I need to rationalize this denominator to get that root 6 irrational number out of the denominator. So what am I going to do? I'm going to times both of these by root 6 on root 6, because this here is equivalent to 1, and we want it to be the same number over there. So timesing it by 1 will give the same number. So let's go ahead and multiply out both the top and the bottom. So remembering that I've got an invisible 1 out the front of my 6 there, I times my coefficients first, which is 3 times 1, which is going to give me 3. And then I'm going to times these two, which is going to give me root 36. However, I know root 36 is the same thing as simply 6. So I'm going to go ahead and do the top now before I simplify out that bottom even further. So again, this is sort of like our binomials we've been doing in previous videos. We have our root 6 times root 2, which is going to give us root 12. And we have our, remember this is a minus 1 out in front there, and this is a plus 1. So plus 1 times minus 1 is going to give us minus 1 out in front. And then our root 3 times our root 6 is going to give us root 18. So we can simplify this down. Now the reason why I know I can simplify this down even further is because I see this is a root 12 over here. And remember, we always want to go through and we want to make sure that there are no square factors. But I know that root 4 times root 3, 4 being a square number because 2 squared equals 4, is the same thing, this here, as root 12. So I'm going to go ahead and rewrite this as 2 root 3 to replace my root 12 over there. And we can probably take out a factor of 9, which is another square number, for this root 18, because I know that root 9 times root 2 is the same thing as root 18. And what's 3 squared? 9. So 9 is a square number representing 3. So I can simply rewrite this root 18 as 3 from the root 9, root 2. So I'm going to head and write that up there. Now remember, I should have included this minus out the front. So I'm going to put minus 3 root 2 on the top. So that's now our simplest form on the top. And now simply to do the bottom, I see all I have to do is 3 times 6, which should be pretty straightforward, which is just going to give me 18. So this whole answer here now in its simplest form is like that. Okay, so we're on part C of question 6 now. So it's going to be our last question. Now I can see here that I have 2 denominators and they're asking me to minus 2 fractions with irrational denominators. So I can choose what I want to do first. Do I want to rationalize my denominators before I minus them? Or should I simply minus them first and then rationalize the denominator? So I think that sounds like a better idea and a quicker idea. So I'm going to do that. So remember, when we want to minus fractions, what do we need to get? We need to get a common denominator. So we can't minus fractions unless they have the same denominator. So we're going to need to rewrite these in the same form. So I know that 3 on 2 root 3 can be rewritten to be in the same form by timesing it by 1. Because remember, timesing it by 1 gives it the equivalent value. So I'm going to times both the top and the bottom by root 2. Now the reason why I've picked root 2 is because we want it to be the same. Now you'll see how this works out in a second. So if I go ahead and multiply those on the bottom and the top, so I'm going to have 2 root 6 and I'm going to have 3 root 2. So this is my new version. This is exactly the same thing as this up here, but we've rearranged the denominator. Okay, so now I'm going to try and rewrite this in a way that also has the same denominator as this one down here. So let's go ahead and do that. I know that I can get the same number, so I've got 1 on root 2 currently, and we're going to try and times it by 1 to get the equivalent number. And I'm going to times this by 2 root 3 on 2 root 3. The reason why I've chosen that is because it is this one over here, and I know that I'm going to get the same value as this other fraction. So then we're going to be allowed to minus them. So what that means, well, I'm just going to have to times these across. So on the bottom, I'm going to have 2 root 6. As you can see, it's the same as over here, so we've done the right thing. And then we're going to go ahead and put 2 root 3 on the top. Okay, so I can now go ahead and minus these because they now have the same denominator. So it's okay now, it wasn't okay before. So that means I'm going to write my new denominator as 2 root 6. And as we can see, it's still got a cert in it, so we'll have to rationalize it after. And we're going to go ahead and minus these 2 from the top. Now, because they do not have the same root there, we cannot actually minus them. So we're going to just leave that on the top how it is. So 3 root 2 minus 2 root 3. Okay, so we've now gotten this far, but we still have one more step to do, which is going to be to rationalize this denominator. Now this should be pretty easy because we've done this in the past few questions. We're just going to have to times it again by 1 because we want it to be the equivalent value. Okay, so what do we got to do? We have to times it by root 6 on root 6 because that there is equal to 1. So let's go ahead and multiply this through. On the bottom, we are going to have, we have a 2 and a 1 as a coefficient, so we have 2 and then root 6 times root 6 gives us root 36, which is the same thing as 6. So over here I'm going to have 2 times 6 on the bottom, and now there's no surd, so we know it's rational, so that's good. And now we're going to go ahead and multiply out this top. So remember, I've got an invisible 1 at the front, and do my coefficients first. So 3 and 1 is going to give me 3 out the front. Root 6 times root 2 is going to give me root 12. Okay, I got my 1 and my minus 2 out the front now. So 1 times minus 2 is going to give me minus 2. And then root 6 times root 3 is going to give me root 18. So now we only have one more thing left to do because we know that we can get a few square numbers out of these two. We know we need to fix this up. So that should be nice and easy. So this root 12, we know from before, because it's exactly the same one, that we can take out root 4 times root 3, because root 4 is a square. We know we can write that as 2 root 3, because 2 is the same thing as root 4. Okay, so we know that's how we can rewrite that 12. And over here, for this root 18, we know that that's the same thing as root 9 times root 2. And because we know root 9 is the same thing as 3, we can write that as 3 root 2. So now don't forget that we need to times by our coefficients at in front. So we're going to times this over here by minus 2 and times this one over here by 3. So our new numerator, our new and improved numerator is going to be 6 root 3 because 3 times 2 is 6. Okay, and then over here we have minus 2 times minus 3, which is going to give me minus 6 root 2. Okay, so that's our new numerator, and we know that's a prime number. That's a prime number, so we cannot simplify that down any further. Now, our last thing, our denominator, which is already rational, we can tell because there's no surds in it, is simply going to be 6 times 2, which is 12. So this should be our fully simplified, rationalized denominator answer.